Hi, Dan from Cloudsmith here. In this video, we will take a look at how you can use Drone CI from Harness to build and publish your packages to a private Cloudsmith repository. So let's get started. Drone CI is a continuous integration platform that you can use to define and execute pipelines using Docker containers. Setting up Drone itself is beyond the scope of this demo, but in short, Drone consists of two main pieces of infrastructure: the drone server and the drone runners. The drone server is where you manage and observe your build pipelines and configure settings, and it's provided as a lightweight Docker image that you can install on a cloud instance, a container service, or even directly on your own hardware. For this demo, I've installed the drone server on an AWS EC2 instance. The drone runners are standalone daemons that poll the drone server for pipelines to execute. In this demo, I will make use of the Docker runner, installed on my local machine. But there are different types of runners that are optimized for different use cases, such as a stateful pipeline that needs to store files on the host machine between pipeline executions. Once you have set up the drone server and one or more runners, you then connect the drone server to your source repositories, and it sets up a webhook that fires when new code is pushed. The drone runners then execute your pipelines. Here we have my drone server, and you can see the source repositories that it has access to. Let's go ahead and activate it for my demo source repository. You can see some of the main settings here, including the name of the drone configuration file from the source repo. We will just stick with drone.yml, the default. The next thing we need to do is add a couple of secrets for this pipeline. We will need our Cloudsmith API key, as we will use this when authenticating to Cloudsmith to push the package that we build to our Cloudsmith repository. We also need to add some authentication to pull the Docker image we are going to use as our runner, as this image is stored in a private Cloudsmith Docker registry. So we just paste this in here as found in our docker config.json file after doing a Docker login, as you usually would to authenticate for Docker. That's it all set up now for this source repo, and we can see in the activity feed that no pipelines have been triggered yet. Let's now go and take a look at the demo project we're going to build. Here is my simple demo project, with my drone.yml config file and a single C source file. Let's take a look at the drone configuration. It starts off by defining the kind as a pipeline and the runner type as a Docker runner, and we've just named it Cloudsmith Demo. Next, we specify the OS and architecture, and then we get into defining the steps that will execute when this pipeline runs. We just have a single step here, a build and push package step. We then declare the Docker image that we will use as the runner. This is a Docker image that I've prepared already. It contains the tooling required to compile my C source and then package it into a Debian package. It also contains the Cloudsmith CLI, which we will use to push the package to our Cloudsmith repository. You could install this tooling right here using commands in the step, but it's cleaner and also makes better use of Drone's container-first approach to build your own image with any prerequisites for the pipeline and use that as your drone runner. Next, we set up our Cloudsmith API key as an environment variable from our drone server. We then execute the make command to compile our C source and use fpm to package this into a Debian package. Next, we use the Cloudsmith push deb command with our Cloudsmith organization name, our repository name, our distribution and version, and our package file name to push the built package to our Cloudsmith repo. Finally, we pull in the secret we added to our drone server that will allow Docker to pull the runner image with our required tooling from our private Cloudsmith Docker registry. So now, let's make some change we can push to the source repo to kick things off. We can just open the C source file and change the message that it prints. That'll do. We now just add this change and then commit the change to our local Git repo. Oh, it's a good idea to sign your Git commits, of course. Finally, to get this pipeline started, we just do a git push to push this change to our source repository. That's it pushed now. If we now go back to our drone server, we can see that our pipeline has started to execute. Let's have a look and see what's happening. It starts by cloning our source repo, and then our build and push package step starts to execute. You can see that it has pulled our Docker image that we are using as the drone runner and has executed make and fpm to build our Debian package. It has then pushed the resulting package to our private Cloudsmith repository. And that's it complete. The package has synchronized successfully. If we now go and take a look at this Cloudsmith repo, and we just refresh the page, we can see our new Cloudsmith drone demo Debian package. And we can see all the metadata that we extracted when we uploaded the package, and detailed contextual install instructions, all generated automatically. I hope that this short demo showed you how easy it is to push artifacts from your drone CI pipelines to your own private repository. If you'd like to try this out for yourself, just go to cloudsmith.com where you can sign up for a free trial. And remember to be awesome and automate everything.